Okay, definition of slope. Given 2 points on a line, let's draw this diagram. A first point on the line has x coordinate x subscript 1 and y coordinate y sub 1. A second point on the line has coordinates x sub 2 and y coordinate y sub 2. From the first point on the left to the second point on the right, there's a horizontal increase in the x coordinates, and there's a vertical increase or vertical change in the y coordinates. And to compute the horizontal change, we take x sub 2, which is a horizontal distance away from the y-axis, and then take x sub 1 and subtract that quantity, that distance, and that gives you x sub 2 minus x sub 1. And if we translate that upward, that gives the horizontal change in the x coordinates from the first point to the second point. And similarly, if we take the distance y sub 2 on the far left, and then the distance y sub 1, which is a vertical distance away from the x-axis, and subtract those two, we get y2 minus y1, which is the vertical change or the vertical distance between the 2 points. x2 minus x1 is also identified as delta x, or change in x, and y2 minus y1 is the change in y, and delta, the triangle, means change in y. So the slope can also be expressed change in y, or delta y, divided by delta x, the change in x. And lastly, slope is also computed from vertical rise divided by the horizontal run. If a line has a positive slope, left to right, the line is said to be rising. If a line has negative slope, it is said to be falling, left to right. If a line has zero slope, then the line is horizontal, and m equals 0. When the line is vertical, the slope is undefined. And the line is up and down vertical. The equation of a line in point slope form, we're going to generate. If we have a point given on a line, say its coordinates are x sub 1, y sub 1, and a second point representing all other points is a general point, and that general point has variable coordinates x and y. So its coordinates are variable because the point is considered dynamic and moving everywhere on the line. And let's also assume we're given the slope m. The slope formula, m equals y2 minus y1 divided by x2 minus x1. We'll substitute x1, y1, which are given coordinates of a point on the line. And for x sub 2, we'll substitute the variable x. For y sub 2, substitute the variable y. So we have m equals y minus y1 divided by x minus x1. This is a proportion which is two equal fractions. On the left, it's m over 1. And in a proportion, you can diagonally multiply across. And when you multiply diagonally, you get y minus y1 times 1 equals the slope m times the quantity x minus x1. And that's the equation of a line in point slope form, which is in the yellow box at the bottom of the page. The equation of a line in point slope form. The next equation in slope-intercept form, we're going to generate from this graph. The line intersects the y-axis at B, and x is 0. So 0 comma B are the coordinates. And a general point with variable coordinates is the point x comma y. Again, applying the slope formula. Slope equals y2 minus y1 divided by x2 minus x1. For x2, we're going to substitute x, and for y2, we're going to substitute y. For x1, we're going to substitute 0. And for y1, we're going to substitute b. So slope equals y minus b divided by x minus 0. That simplifies to y minus b divided by x. And again, in a proportion, which is two equal fractions or ratios, we can multiply diagonally. So we get y minus b equals m times x. And we add b to both sides, so we get y equals mx plus b. And that is the equation of a line in slope-intercept form. And that's summarized in the yellow box at the bottom. When lines are parallel, they are in the same plane or coplanar. They have no intersection point, no common point. And lines are labeled with lowercase letters. So here's a line A and a line B. To indicate parallel lines, sometimes we'll see arrowheads or kind of a squiggle mark. So a pair of arrows or a pair of squiggle marks. And when lines are parallel, they have equal slopes. That can be expressed. The slope m of line A equals the slope of line B. Lines are perpendicular when they intersect at 90 degrees. So at the intersection, there are going to be 4 90-degree angles. One line has a positive slope. Let's say line A, line B has a negative slope. And we can write A is perpendicular, here's the symbol upside down T, to line B. Now the slopes are opposite in sign, one's negative, one's positive, and their slopes are reciprocals of one another, negative reciprocals. So the slope of line A is opposite in sign, so we have a -1, and that's divided by the slope of line B. And in words, that is said, their slopes are negative or opposite in sign and reciprocals. If we cross multiply, use the cross product rule on this proportion, we get the slope of line A times the slope of line B. So the product of their slopes when lines are perpendicular is -1. Product of their slopes is -1 when the lines are perpendicular. Exercise, graph the line that contains the point 1, 3 and has a slope of -2/5. So we can start off plotting the point at x is 1, y is 1, 2, 3. It's a given point P. And the slope has a negative sign in the middle of the fraction bar. And you can either write the negative sign in the numerator and have the denominator be positive, or that's the same as a +2 divided by -5. Either way, so from the starting point, 1, 3, if we use the -2, then we'll go down 2 units. And the denominator is a +5, so we would horizontally run to the right 5 units, and we'll be at x is 6. And then draw the ruler, the line through those 2 points, pretty close. Or you can use the +2 and go up 2, vertical rise up 2, and a -5 horizontal run would be to the left 5 units. Find the equation of this line in point slope form and slope intercept form. Point slope form is y minus y1 equals slope m times x minus x1. So we'll substitute the given y1, which is 3. Slope is -2/5. And x1 is 1. And that is point slope form. Slope intercept form is when you solve for y. So to solve for y, we'll distribute the -2/5 and then add 3 to both sides. So y equals -2/5 x plus 2/5 plus 3. And add the fractions, we need a common denominator of 5, so we'll multiply by 5/5. So the equation in slope intercept form is -2/5 x plus 17/5. Find the equation of the line L. First, we need to find the slope. So from left to right, let's find the horizontal run, which is to the right 1 unit, 2 units, 3 units. So the change in x, or the delta x, is positive because it's to the right 3. And the increase in y, or the change in y, is upward 1 unit. So the delta y is +1. So that ratio of delta y to delta x is 1/3. And so that's the slope. So the equation is y equals mx plus b. The slope m is 1/3. So y equals 1/3 x plus b, the y-intercept, which we're going to calculate. We can use either point on the line. So if we used the point -1, 1, we substitute 1 for y, substitute for x, -1, and then solve for b. So 1 is -1/3 plus b. Add 1/3 to both sides. So 1 plus 1/3 is b. That's 1 and 1/3, which is 4/3. So b is 4/3. So the equation in slope-intercept form is y equals 1/3 x plus 4/3. Find an equation of line L, the line with the positive slope, if it's given that it's perpendicular to the line y equals -1x. The slope of the other line is the coefficient of x is -1. Since the lines are perpendicular, since that's given, the slope of L is opposite in sign, so +1, and the reciprocal of 1, which is 1. So since line L is perpendicular, right? That's the symbol for perpendicular to the other line, y equals -x. The slope of line L, which we could abbreviate as m subscript L, is +1. So the negative reciprocal is positive. And again, the reciprocal of 1/1 is 1/1. So the equation of line L is y equals mx plus b, where b is the y-intercept, which appears to be 2 on the graph, but we're going to calculate it to be sure. So we have y equals +1x plus b. Line L contains the point -1, 1. So using that point, we're going to substitute -1 for x and +1 for y. So we have 1 equals 1 times -1 plus b. So we'll add -1 to both sides to solve for b. So b equals 2. So the equation is y equals x plus 2. Find the equation of the line parallel to the line y equals -3x containing the given point -1, 2. The lines are parallel, and therefore they have equal slopes. The equation y equals -3x has a coefficient of -3. That's m, the slope of the line. So we know the slopes are both m equals slope equals -3. So the equation will be y equals mx plus b, y equals substitution of -3 for mx plus b. Now to solve for b, we use the given point, x is -1, y is 2, and substitute 2 for y, substitute -1 for x, and solve for b. So 2 equals 3 plus b gives b is -1. So the equation is y equals -3x plus -1, which is the same as same as -1. So that's or y equals -3x minus 1 is the same. Find the slope, y-intercept, and graph the line 3x plus 2y equals 6. So one method is to solve for y, take the given equation, isolate y, to get the slope of the line, which is the coefficient of x, and b, which will be the y-intercept. So let's write the given equation and begin isolating y. We'll subtract 3x from both sides. So on the right side, the x term becomes -3x after subtraction plus 6. We divide by 2, which could be done with the mental math step here. And 6 divided by 2 will be 3. So in slope-intercept form, this is y equals a slope of -3 divided by +2, x plus 3. Therefore, the slope is -3/2. That's the ratio of rise over run. And the y-intercept, b is 3, or the point 0, 3. So to graph, we'll start with the y-intercept at 0, 3. 1, 2, 3. First point. And the slope is a rise of -3, so we'll go down 3 units to the origin. And then the horizontal run is +2, so we'll go to the right 2 units. We'll be at +2, plot a point, and draw the line with your ruler through those 2 points. And that's the graph of the equation.